turns out that the length of the cross product of u cross v is the length of u times the length of v times the sine of the angle between u and v. And the proof, it's not a simple proof, but well, all it does is use a lot of facts that we already know. The cross product of a vector squared is just u cross v times itself, times the dot product of u cross v. But now by one of the properties we've shown in the properties of our cross products is that this is u dot v cross u cross v. Okay. Now, this is the same as u dot, whatever inside those parentheses. For one of the properties that we showed earlier is that this is our u dot v cross v dot v in the u direction minus, what is it, v dot u in the v direction. This equals, now this is a scalar, so it's u dot u. So it's the scalar times u dot u. Minus, this is the scalar v dot u, so you do u dot v. U dot v. So now, what do we have from here? Well, this here is just the length of u squared times that there. Remember, multiplication commutes. Well, that's the length of v squared minus v dot u times u dot v. V squared. Now, we know the following. We know that u dot v is equal to the length of u times the length of v times the sine of the angle between u and v. Well, that's, and you know, this is also v dot u. So this is v dot u, and this is u dot v. So we have the length of u squared times the length of v squared minus this squared. The length of u squared times the length of v squared times the sine of the angle squared. Well, here I can factor out the length of u times the length of v squared. And I'm left with 1 minus sine square theta. So this becomes, now, something seems to be wrong here. Oh, I apologize. This should have been cosine. U cross v, u dot v, is the length of u times the length of v times the cosine of the angle between u and v. So this should be cosine theta squared. Oh, I guess I can put the square in. Sorry about the silly error. Minus the cosine squared. So now when I factor out the length of u times the length of v, well, what I mean to say is I already did that. That's sine square theta. So here's where the proof comes together. we've shown that this equals that. So the lengths of u cross v, which is never negative, is equal to the square root of the right side. The lengths of u times the lengths of v times the sine of theta. And we will use this fact in the next theorem. So maybe we can call this a lemma. If you like videos like this where we prove everything, subscribe to my channel, leave comments, tell your people about my YouTube channel. Most of all, watch and learn. See you in the next video.